Hi everyone, good afternoon. My name is Shayla May A. Andino, and today I'll be tackling the chapter 10, which is the statistics and computer tools for analyzing of assessment data, together with my co-reporter Elaine Ligayan and Lani Espon. So this chapter aims to utilize process data and results in reporting and interpreting learners' performance. So there are also three types of statistical measures mentioned in this chapter. So these are the measures of central tendency, the measures of variations, and the measures of relationship. But I will be discussing the measures of central tendency, and as for the rest, it will be discussed by my co-reporter later on. So now let's discuss what is statistics. So statistics helps teachers to first analyze and describe results of measurement obtained in their own classroom. Second one is they help to understand the statistics used in test manuals and research reports. And third, they help to interpret the various types of derived scores used in assessment. So these statistics or these statistical methods enable us to look at information from a small collection of people or items and make inferences about a larger collection of people or items. So there are two types of statistics. The first one is the descriptive statistics, and the second one is the inferential statistics. So the purpose of this descriptive statistics is to provide a clear summary of the data collected. And the scope of this one is limited to the data at hand and does not go beyond the data sets. So the data required for this one, it could be the entire population or a sample of the population. So this descriptive statistics, it also deals with measures such as central tendency or the mean, median, and the mode, the dispersion or the range, variance, and standard deviation, and the data visualization or what we call the graphs, tables, and the charts. So in descriptive statistics, there is what we call the numerical indices. So these numerical indices are values used to summarize specific aspects of data. So it is a representation of a data set. So there are two types of numerical indices. So the statistics are the indices calculated using samples drawn from a population, while these parameters is when the indices are calculated using the entire population. So now let's discuss the second type of statistics. So this inferential statistics, it uses the sample data to draw conclusion about the population and extends beyond the dataset to make a broader conclusion. So there are two types of tests in inferential statistics. So these are the parametric test and the non-parametric test. So this parametric test assume that the data follow a certain distribution, typically a normal distribution, and they rely on parameters such as the mean and the standard deviation of the population. So these tests are more powerful if their assumptions are met. So one example of this one is the person correlation. On the other hand, non-parametric tests do not assume a specific distribution of the data, making them more flexible and applicable to a wider range of data types. So these are often used when the assumptions of parametric tests are not met. So it can be used with ordinal or nominal data, or when the data is heavily skewed or has outliers. So one example of this one is the Spearman correlation. So now let's proceed to statistical tools. So to carry out meaningful comparisons among sets of test scores, a statistical tool is needed. So the measures of central tendency and the measures of variability are the most commonly used statistical tools. So I will now discuss what is measures of central tendency, and the measures of variability will be discussed by my co-reporter later on. So I know that you are already familiar with these measures of central tendency. So now let me recap what is mean, median, and mode. First is the mean, or also known as the arithmetic mean, is one of the most commonly used measures of central tendency. It represents the average value of a dataset and provides a single value that summarizes the overall distribution of the data. The median represents the middle value of a dataset when the values are arranged in order. So the median divides the datasets into two equal halves with 50% of the data values falling below it and 50% above it. The mode focuses on frequency rather than numerical position or averages, making it particularly useful for categorical.
Good afternoon, everyone. This is the continuation of the chapter 10. So measures of variability like standard deviation describe how spread out a set of scores is. A higher variability indicates scores are more spread out, while a lower variability means scores are clustered closer together. The range is the spread of your data from the lowest to the highest value in the distribution. Example, if the dataset is 2, 5, 8, 1, and 3, then the range will be 10 minus 2 equals 8. So our range is number 8. The quartile deviation can be defined mathematically as half of the difference between the upper and the lower quartile. So imagine that the class test scores are divided into 4 equal groups. The quartile deviation measures how spread out the middle two groups are. A larger quartile deviation means the middle scores are more dispersed. Standard deviation is a statistical measurement that looks at how far individual points in a dataset are dispersed from the mean of that set. So example, a class test scores with an average of 80. A standard deviation of 5 means most scores are within 5 points of the average, between 75 and 85. A higher standard deviation implies scores are farther from the average. So a z-score is a way to measure how far from the mean each of your data values is using a standardized scale. So example, a student scores 85 on a test where the average is 80 and the standard deviation is 5. Their z-score is 1. It is because 85 minus 80 equals 5. Then divide to 1 equals 1. So a positive z-score means they scored above the average. A t-score is equivalent to the number of standard deviations away from the mean of the t distribution. So a t-score is like a z-score, but with a different scale. A t-score of 50 is average, and each point above or below represent one standard deviation. Standard 9 is a method of scaling test scores on a 9-point standard scale with a mean of 5 and a standard deviation of 2. So here are test scores from 1 to 9, as the 9 score of 5 is average. Scores above 5 are above average, and scores below 5 are below average. And the best score or the highest score in the standard 9 is 9. The next one is percentile rank. In the world of statistics, percentile rank refers to the percentage of scores that are equal to or less than a given score. Example, a student scoring at the 80th percentile on a test. This means they scored higher than 80% of the other test takers. So our percentile rank here is 80. So indicators of relationship, also called measures of association, are statistical tools that help us understand how two or more variables relate to each other. Example, a study looking at the relationship between hours spent studying and test scores. A product moment correlation, or often called Pearson's correlation, would measure the strength and direction of this relationship. A correlation of class 1 would mean a perfect positive relationship. So graphic presentation are visual representations of data that use charts, graphs, and other visual tools to make data more accessible and easier to interpret. Example, the histograms and box plots. These are visual ways to represent data and show its distribution and variability. A histogram shows the frequency of different scores, while a box plot displays the quartiles and outliers. Then the last one is the product moment correlation, or also known as Pearson's correlation coefficient. Example, you're trying to figure out if there's a relationship between two things, like how much you study and how well you do on a test. So the product moment correlation is a way to measure how strong the relationship is.
Good day everyone, my name is Lanis Polo and I am the last reporter of this lesson. So, rank order correlation coefficient. So what is the rank order correlation coefficient? The rank order correlation coefficient is a statistical method for measuring the relationship between two variables, especially useful for rank data or ordinal data, and it's computationally simpler than Pearson correlation. Measurement scales different ways of measuring data, including interval, equal intervals, no true zero, ratio, equal intervals, true zero, and ordinal rank data. Next is basic step in opening the Miss Excel program. So click the Miss Excel icon. If the icon isn't visible, click the Start button. Select all programs and double-click Miss Excel. So in the initial window, if using the latest version, click the blank documents. As you can see that they have a option, and otherwise double-click open the other worksheet to open previously saved file. So next is once a worksheet has opened, it is now ready for data entry. You may now encode the scores or data that will be processed. The worksheet is like this, as you can see the picture that given. So now we may start including our data. We start our discussion with the charts and frequency distribution. So next is the charts and frequency data. So charts and frequency distribution, the table below contains the grade of 10 students and their mathematics and English subject. The first column is the student class number, second column in the math grade, and the third column is the English grade. So using the encoded data, it may be converted into charts and or diagram. So next picture, click the Insert tab, then among the chart option, choose Insert Scatter. Note, user can choose chart types, bar graphs, pie charts, line graphs, or etc. based on their data presentation preferences. So, makapili ka diri o lahi-lahi nga types of charts. Depende siya sa references o sa imo ang data presentation. So next is computing for the measures of central tendency, variability, and correctional. So to compute measure of central tendency, variability, and correctional in Miss Excel is ingani-on siya. And then, so naa siya 3 steps. First one is click the formulas. Click the Formulas tab. Step 2, choose More Functions, the Statistical. Step 3, select the appropriate statistical formula for the given example average for the mean. So for the mean, choose average from the list once you click the function average. The following screen will be displayed. Kanio. Kita ninyo? That's all. Thank you for listening.